This video clip is going to show you how to write the conclusion for the experiment for the reaction rate versus the amount of reactant, and also the discussion and evaluation and the science ideas behind it. So we'll start here with the conclusion. So write a conclusion from your process data that will link your findings to the purpose of the investigation. So first of all, we have to find out what the purpose of the investigation was. You can flick back to your first page or scroll back up to it if you're using the digital version, and the purpose was to determine how changing the amount of hydrochloric acid affects the rate of reaction between hydrochloric acid and magnesium ribbon. So if we go back down to our conclusion, we now know our purpose, and we have to link that to what we found. So we can restate the purpose first of all. That's always a good place to start because it gets it clear in your head. So the purpose of the investigation was to see how reaction rate is affected by the amount of the reactant. Now, our reactant was hydrochloric acid. That's the thing that we changed the amount of, so we can say that the reactant was HCl in this experiment. Okay. If we look at our graph and also our average table, now this is a graph that I did digitally for a different video, so that's why it's like that. Some of you might have a hard copy graph that you've drawn yourself. But here are the results that have created this graph. If we have a look at this graph, we can see that as the amount of hydrochloric acid increases, then the reaction rate decreases until it gets to this point here. So this is the lowest reaction, or the quickest reaction rate here, and then it slightly, very slightly, takes slightly longer when we go up again. So you can see this here in the results as well, that at 15 mils the reaction rate took 26 seconds, but at 20 mils it took 27 seconds. And that can happen because you can get something called substrate concentration or optimum levels being reached. We won't worry about that too much in too much detail yet, but it's just explaining why this happened. So we've got to include that information somehow in here. So we can say our results show that as the amount of reactant increases, the reaction rate decreases. However, at 20 mils of reactant, the reaction rate was slightly slower than at 15 mils of reactant. So we've said what our results show, which is that the reaction rate decreases as the amount of reactant increases, but we've also explained our odd data point, and we've linked that back to the purpose of the investigation, which was to see how reaction rate is affected by the amount of the reactant. So what we should do now is include some data points. So we've already put in a few, but we'll add in some extra ones too. So we'll say our fastest reaction rate was at 15 mils when the bubbles produced by the reaction reached the 7 centimetre line in only, and we can look back at our graph to find out the number, or our average table, at only 26 seconds. Compared to taking, back up here, 57 seconds at 5 mils of HCl. And that would be a fine conclusion because it includes the information about the purpose, information about what we were doing, what our results show, how that links to the purpose, and then some specific data points as well. Okay, moving on, we're going to skip this next part for a second. So ignore this bit, we'll go back to it, and we're going to look down here instead where we have to write our evaluation. So write a justification of the procedure you used, including the choices you made to increase accuracy and reliability. We'll start with accuracy first. So we increased accuracy during this experiment by, now we go back up to where we talk about how we did that. So there's a box specifically for it under the planning stage. So we said we will repeat our experiment at least 3 times, then average the results and remove any outliers, and we will make sure we measure chemicals accurately to avoid parallax error by reading the measuring cylinder, looking at eye level at the base of the meniscus. So we can copy those 2 things down. You can copy it if you're on a computer, otherwise you can just rewrite it. And we'll stick it in this box by, firstly, repeating our experiment at least 3 times, then averaging the results and removing any outliers. We also made sure we measured chemicals accurately, avoiding parallax error by reading the measuring cylinder, looking at eye level at the base of the meniscus. This increased the accuracy of the investigation. So now we've covered the accuracy part, we're going to look at the reliability part. To make our results reliable, we controlled a number of variables. For example, and then we go back up and we look at what variables we did control. So we controlled temperature, and we can possibly look, we've written it in our method, but we can look at our planning because it might be a little bit easier to copy from. We controlled temperature, we controlled the finish line for the bubbles, we controlled the amount of detergent we used, and we controlled the size of the magnesium ribbon. So if we take all that information, and again you can copy it if you're on the computer, or you can just flick back and forth between it if you're doing a hard copy as you rewrite it. We'll put that information in. For example, we controlled temperature by making a 20 degrees Celsius water bath using a cold water tap and a beaker and a thermometer. We did this because, so we're saying here what we did and why we did it. We did this because, so the why we did it is in red, the how we did it is in blue. We did this because temperature affects reaction rate. Higher temperatures cause reaction to happen faster because higher temperatures give particles more energy to move around and collide with other particles faster. Okay. The second variable we controlled was the finish line on the test tubes for the bubbles. We marked a line using a vivid and a ruler from the base of the test tube to 7 centimeters high, and we did this because we must keep the finish line the same so that it is a fair test. So we'll take this and put it in red because we did this because yours doesn't have to be in different colours, but for you guys to see it, it probably makes it a wee bit easier. Next, we controlled the amount of detergent. So we can put that bit in blue. We only used 5 drops. 5 drops in each trial. Why did we do this? Because if we used more or less detergent, we would have got more or less bubbles. Therefore, it wouldn't have been a fair test. And then finally, we controlled the size of the magnesium ribbon. We used a 2 centimetre millimetre size piece. If we had used or had less magnesium, then we would have got less reactions, and more magnesium would have caused more reactions. Therefore, that wouldn't be a fair test. Okay, finally, to sum that all up and say why we did all those things was because if we look back at the top of this box, it says that we are trying to increase accuracy and reliability. So we can say we increased the accuracy and reliability of our investigation by avoiding parallax error, repeating our experiment 3 times and averaging the results, as well as controlling numerous variables. Okay, so that is a good evaluation because it includes information about how you made it accurate, how you made it reliable, what control variables you controlled, how you controlled them, why you controlled them. So that is the basic formula for writing that. Now we need to go to this box here, which we've skipped, and we need to change this because it is incorrect. So our investigation is related to the amount of reactant and reaction rate. Now this information here, you haven't covered it yet, so that is actually viewable on video clip number, just have to find the number, video clip number 7. So you need to watch video clip number 7 about the amount of reactant and reaction rate, write the notes into your book, answer the questions that the video clip asks you, and then you can come back and put it into this box here. So you might like to pause it, do that now and then come back to it, or you might like to go and do that work and then come back to this later.